and you're going to learn about inverse trig functions. Isn't that what we're learning about? Inverse trig functions. Okay, hush. So inverse trig functions are you plug in a number and you see what the angle is. Kind of what we were doing in that last section. Okay. So evaluating graph, inverse sine function, evaluating graph, inverse trig, the other trig functions. We're just going to learn about inverse sine and inverse cosine, inverse tangent. And then I think we are going to save evaluating compositions of trig functions until tomorrow, because we're going to spend 2 days on this. All right? So inverse sine function. So the first thing about an inverse sine function is that, here I'm going to take a picture of this so that we can, I can post this and I can write on top of it. Okay? So we have known that for a function that is one-to-one, it must pass a horizontal line test. In the figure, it's obvious that y equals sine of x does not pass the test because different values of x yield the same value of y. In other words, if I were to draw a horizontal line here, horizontal line, it would cross this graph lots of times, right? Infinitely many lines. And in order for something to be a function, when you put one thing in, you need to get one thing out. You can't get out multiple things, okay? And so if I want to graph the inverse, I have to do something called restricting. I have to restrict it from here to here. So, do you remember how I sketched the graph of an inverse? You guys remember that? I flip it over some line. Do you remember? I flip it over this line, y equals x. You kind of remember that? Maybe? Pretend you're not here to say, yeah, that's what I remember. Okay? So y equals x. So if I were to flip this over the line y equals x, I would get something that goes back and forth forever, up and up, and it wouldn't be a function. So if I plugged in the x value, I would get out infinitely many y values. So with the inverse trig functions, they need to cut off these functions here and here so that for every x value, I'll get out exactly one y value. And the reason they decided to cut it off here and here, because if I cut off like here and here, then it still wouldn't pass the horizontal line test. You understand? So the horizontal line test, if a function doesn't pass the horizontal line test, then its inverse won't pass the vertical line test. Okay? Remember that? That's the horizontal line test. And so what they do is they restrict the domain of the function. So for sine of x, they restrict the range to being -1 to 1. Okay? Whoops. They restrict the domain from, this would be, what value would this be if this were y equals sine of x? What's this point right here? If this is negative pi and this is positive pi, what point is this? Negative pi halves, right? Negative pi over 2 and positive pi over 2. So what they do is they restrict the range of the function. So we'll move on. Let me show you. Because you'll see. Okay? When you restrict the domain to the interval negative pi over 2 to pi over 2, which is what I just showed you, corresponding to the black portion of the graph, which we would go back. We go back? There we go. That's negative pi over 2 to pi over 2. Okay? If we restrict the domain of the function, then okay, corresponding to the black portion, the following properties hold. On the interval negative pi over 2, the function y equals sine of x is increasing. On the interval negative pi over 2 by y takes on the full range of values for sine between -1 and 1. On the interval negative pi over 2, y equals sine x is 1 to 1. Okay? So on the restricted of blah, 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 they call this inverse sine of x. The notation of inverse sine of x is consistent with the inverse, but the arc sine notation has the arc sine, blah, blah, blah. Okay? So what this means, okay, is when you're on the unit circle, okay, and say they want this thing called inverse sine of x. Also known, another name for it is arc sine. Okay? So in this book, they tend to use arc sine of x more than inverse sine. It means what angle has a sine or a cosine of this number. Okay? And you're only allowed to look for that answer going this way or going this way. Okay? So this is, they call this positive pi over 2. But in order to be consistent with that graph I just showed you, you only look for your answer here or here, even though there are multiple places where sine is equal to something. For instance, if I said inverse sine of 1/2, okay, what is the answer to this? This says, where is sine equal to 1/2? Okay, not at 60 degrees, 30 degrees. 30 degrees. We're having a quiz on the unit circle tomorrow, so you should know these things. Okay. Inverse on memorization quiz. You have to reproduce the unit circle from scratch. Okay. So inverse sine of 1/2 is equal to 30 degrees, which is pi over 6. What if I said inverse sine of -1? Who knows what that would be? Where is sine equal to -1 between and including the endpoints? Here or here on your unit circle? Where is sine? 200, yeah, but that's not in between. That's not, you have to restrict the places you can look between -pi over 2 and pi over 2. So you have to restrict, since you restricted the domain on the original function, this is the inverse function, so we're restricting the range. So we're restricting where we can look for the answer. So where can I look for the answers? Yes, sir.
So does that mean that it doesn't include the y-axis?
It does include the y-axis.
Okay.
Yeah, okay. So where can I look?
-pi over 2.
-pi over 2. This is -pi over 2. Or negative, it's in degrees, -90 degrees. So when you're looking for inverse sine, you only look in the fourth quadrant, going backward, but you can't call this thing, you can't call it 270. Okay, or you can't call it 3 pi over 2. You have to call it -pi over 2. Because when I graph inverse sine, and I'll show you this in a minute, okay, the graph of inverse sine looks like this. And it goes from, the only values I can plug in are from -1 up to +1, and the y values that I get out go from -pi over 2, -pi over 2, up to positive pi. So this mark up here, that's positive pi over 2. So that's the point. So where I'm looking on this graph is when is sine -1, it's equal to -1 and -pi over 2. But you get those answers from your unit circle, not really from the graph. Okay? And if you were to plug that into your calculator, you should get about whatever -3.14 divided by 2 is. So 1.6 something, 1.67 or something like that. Okay? So going back, I know this is lots of math talk, right? That's what I kind of like to teach you. So this is what it says. The inverse, so I'm going to take a picture of this for those of you who want to see it. So definition of inverse sine function. The inverse sine function is defined by y equals arc sine of x, also known as y equals inverse sine of x. Same thing. Okay, so this means exactly the same as y equals inverse sine of x, and there's a button on your calculator for that inverse. Okay, if and only if sine of y equals x, where -1 and 1 are the domain, and -pi to pi over 2 are the range of the function. And notice that this has square brackets, meaning I can plug in points at the endpoints. All right. So if you were to go on your calculator, which I'm going to show you right now, you hate this? What's wrong?
No, it says wait.
Wait. Oh, you want to write things down. I'll move the calculator so you can see it. I have ways. I'm very technically savvy, sort of. Okay. So I'm going to go view, always in front, always in front. And then if I, doesn't move. There it moves. So say I want to find inverse sine. Like I said, first I want to make sure I'm in mode radians, which I am. And if I want inverse sine of -1, second sin, that's how you do it, okay? What was the first sin? Okay. Of -1, okay? I hit enter, and I get about what I said, -1.57. Okay, so that's like negative pi over 2. If I, right? Second pi divided by 2, okay, equals that same number, right? So that's what it is. What if I tried to do second sin of -3? What would I get out? It doesn't work. Why not? Why does it work? Come on. Why does it work? What? You come in here. Everybody have to yell your phone. We got a buzz. So anyway, why doesn't this? Look what happens if I try to do second sin of 3. Boom. Boom. What do I get out? Error. Why? Yeah, because you can. Well, also sine never gets bigger. It's the opposite side over the hypotenuse side, right? Never gets bigger than 1, and it never gets less than -1. So you can't plug in an answer in there. The opposite side over the hypotenuse side is never bigger than 1, and that's why you have to restrict what you could plug in there. Okay, so let's go back. You got that? You understand what inverse sine is, where you look for inverse sine, and so on and so forth. Okay. Let's go on to inverse cosine. So don't look. Let's go back. Okay. Let's take a picture of this. Let's see how good you are. You already saw the first answer, but so who can tell me this answer right here? What's the inverse sine? Inverse sine or arc sine of -1/2. Where is sine -1/2 between -pi/2 and pi/2? -30 degrees or -pi/6. Okay? We got to think in pi. Okay? Where is inverse sine root of 3/2? Unit circle. Hello. Come on, you gotta know this. Pi/3, very good. Pi/3 or 60 degrees. I wrote pi/3, 60 degrees. Okay? How about this one? Error. Okay? Undefined. You're going to get an error. Because you can only plug in numbers between -1, positive. Is that easy so far? Good. All right. Next. Look, we got them all right. It is not bad. Sketch the graph. We already did that, right? I already showed you the graph. So they kind of show you can make a table of values from this, okay? And -pi/2, sine is -1, -pi/4, and then they just plot those points, and you end up getting the graph. The graph looks like this of inverse sine, which is kind of, I'm going to take a picture of it again so that people who want to see this can see it in my notes. But inverse sine, -1, -pi/2, -√2/2, -pi/4, 0, 0. And it goes up like that, and the domain is restricted like that. Okay? So if you graph inverse sine, you get something like that. You have to play with the window, because it's kind of a weird window. It only goes from -1 to 1 and from -pi/2 to pi/2. But if you're in radian mode and you set up your radians, you should get a nice little curvy graph that looks like that. And if I didn't restrict that domain again, it would keep going like this, in which case you have infinitely many values. So that's why, restrict the range. Mason. Okay. Hey. So anyway, let's move on. Let's move on to what's next. Oh, other inverse trig functions. So the next one they're going to talk about is inverse cosine. Okay, and inverse cosine you have to restrict a little bit differently, because if I restricted it to the same places from negative pi over 2 to pi over 2, then it wouldn't pass the horizontal line test, and I get multiple answers if I plugged in a value for, like, try to figure out like where cosine is root of 2 over 2. So what they do with inverse cosine, what you have to do with inverse cosine is restrict it to one top to bottom, which goes from 0 to pi. So when I'm graphing my inverse cosine function, I'm just going to sketch a graph of what it looks like. Okay? So when I'm graphing my inverse cosine function, it also goes from positive 1 to negative 1, right? But it goes between this is negative 1, positive 1 on the x-axis, okay? Goes from, because this is 1 and this is negative 1. So it's going to go from negative, the values that I can plug in have to go from negative 1 up to positive 1. But the values that I get out are going to go from only from 0 to pi. So if I plug in, it's going to start up here at negative 1 to positive 1. From 0 to pi. Whoops, is going to go from 0 up to pi. So at pi radians, what is, so think of it backwards. Pi radians, what is cosine? What's cosine of pi? 100 units circle. Negative 1. Okay? So at negative 1, cosine is going to be pi. And it's going to do a little squiggly thing and kind of come down here and look like that. Okay? Because cosine is 1 at 0 radians, right? Okay, so you have to kind of think backwards. So this is how the graph of cosine looks like. Inverse cosine. So let's just look at what they say. And they plug in these values to come up with it, okay? And make a little table. Oh, we're not going to talk about tangent yet. We'll go back to tangent. But inverse cosine goes between negative 1 and 1, and the range is between 0 and pi. So what that means is for inverse cosine, you just look for your answers between 0 and pi. So you look in the first and second quadrant for your answers. Okay, so let's see if they give us some problems to work on. We'll talk about tangent in a minute. So say I want to find arc cosine of root of 2 over 2. Where is cosine in the first or second quadrant? Where, here, or here is cosine equal to root of 2 over 2? And what is that angle corresponding to? 45 degrees. Okay? So that is equal to 45 degrees, or in radians, that's pi over 4 radians, right? What would inverse cosine, where between 0 and 180 is cosine equal to negative 1? Where would it be? At 180, or pi radians. 180 degrees, pi radians. What if I said, what is the inverse cosine of negative 1/2? Which quadrant am I in? That's right. Who said that? Excuse me? It's 120 degrees, or how many? What's that in radians? Is that 2 pi over 3? Okay. 2 pi over 3 radians. Because cosine is also negative 1/2 down here, right? But that's not in my range of my function. So if if I plug, so cosine is also negative 1/2 here, but the inverse cosine, in order to make it a function, I can only have one answer out. So the answer that it's going to give me is in the first or second quadrant, and it's going to be over there. All right? Yes? Good. Okay. So going back, where did my PowerPoint go? Going back, you also restrict tangent. I haven't talked about that yet. But our tangent is, its domain goes from negative infinity to infinity, and the reason for that is because tangent, if you think about the tangent graph, oh look, I can do it right there. Remember tangent? It has asymptotes at negative pi over 2 and pi over 2. Nope, it doesn't go that way, it goes the other way, okay? Tangent goes like this, sorry, always does that, okay? So there's the graph of tangent, okay? So inverse tangent, it looks, they restrict the range to be between negative pi, well you have to restrict the range, to be between negative pi over 2 and pi over 2. So when you're looking for answers to our tangent problems, you look in the first quadrant and the fourth quadrant, okay? Just like for sine. So sine and tangent, you look for in quadrants 1 and 4, and inverse cosine, you look for in quadrants 1 and 2. Just so you know, inverse tangent, if you were to graph it, it just looks like this, kind of twisted on inside and backwards. So if you were to graph it, it looks like inverse tangent. Goes like this, goes like this. It has asymptotes here at pi over 2 and here at negative pi over 2. So this is pi over 2, this is negative pi over 2, and this is the x-axis, and it kind of comes up, starts down here, has an asymptote, goes up here, and has another asymptote, okay? And that's what the graph of inverse tangent looks like. Inverse tangent, what's its domain? From looking at the graph, what's it? You can plug in any number, right? Because the ratio of the opposite side to the adjacent side can be any number, right? If the opposite is bigger than the adjacent side, you could go to infinity or negative infinity, right? But it can only but you can only look for that answer between negative pi over 2 and pi over 2, okay? And so let's go to those next couple problems over here. So what's the arc tangent of 0? Where between negative pi over 2, between here and here, is tangent equal to 0? How many radians? How many degrees? Where is tangent equal to 0? Right here, at this point, 0, comma 1. Right. That's 0, that's 1 comma 0, one more, okay? That's 1 comma 0. Y over x, 0 over 1. So our tangent of 0 is equal to 0. What's inverse tangent of 1? Negative 1. Come on, where's that? Where between negative pi over 2 and pi over 2 is tangent equal to negative 1? Where? Perfect, okay? Down here at negative 45 degrees. Do you guys understand where Catherine got that from? Okay? So it's tangent when the ratio of the opposites and adjacent are the same. It's a 45-degree angle. So down here at negative 45, also known as negative pi's over 4 radians. Statius! Guys, what is it? Do they put something in the water at lunchtime that you start? Oh, I just started.